Good day everyone, I am Crystal Jean Arcala from ACT1B. At this point, we will explore data representation and storage. Data representation and storage is the process of converting information into a format that can be understood and manipulated by a computer. This includes how data is structured, stored, and processed in the system, while data storage refers to how and where data is kept for long-term, temporary use so that it can be retrieved, updated, and deleted later. Data representation and storage form the backbone of modern computing, enabling efficient processing, analysis, and sharing of information. These interconnected concepts encompasses various techniques, technologies, and methodologies that facilitate the capture, organization, and management of data within computer system. Now, let's move on to the number systems. Number system is a method of representing numbers using specific rules. It provides a consistent way to express numerical values. In computing, information is represented in binary form using digits 0 and 1. However, there are other number systems such as decimal, octal, and hexadecimal that are often used for human understanding and convenience. Here are the most common number systems. The first one is the binary number system. It is base 2 from 0 and 1. Second is decimal. It is a base 10 from 0 to 9. Third is octal. It is a base 8 from 0 to 7. Then hexadecimal. Base 16 from 0 to 9 and 8 to F, where A represents 10, B represents 11, and so on. Now, let's explore binary to decimal conversion. Here are the steps to follow when converting binary number to decimal. Step 1. Write down the binary number and assign powers of 2 to each digit. Each position in a binary number corresponds to a power of 2 starting from the right. Step 2. Multiply each binary digit by its corresponding power of 2. Then step 3. Add the results. Here's the solution. Here's the solution. 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, and 2 raised to the power of 3. 1 times 2 raised to the power of 3 is equal to 1 times 8 equals 8. Then, 1 times 2 raised to the power of 2 is equal to 1 times 4 raised to the power of 4. 0 times 2 raised to the power of 1 equals 0 times 2 equals 0. Then, 1 times 2 raised to the power of 0 equals 1 times 1 equals 0. Then add 8 plus 4 plus 0 plus 1 is equal to 13. So the decimal equivalent of the binary number 1101 is 13. Now, to check if the conversion from binary to decimal is correct, you can reverse the process and convert the decimal back to binary. Here's how you can do it. Take the decimal number you obtain, then divide the decimal number by 2. Continue dividing the quotient by 2 until the quotient is 0. Then write the remainders in reverse order to get the binary equivalent. Here's the solution. 13 divided by 2 equals 6 remainder 1. 6 divided by 2 equals 3 remainder 0. Then 3 divided by 2 equals 1 remainder 1, and 1 divided by 2 equals 0 remainder 1. Now, write the remainders from bottom to top. So that will be 1101. So the decimal equivalent of the binary number 1101 is indeed 13. Next is decimal to binary conversion. Here are the steps to follow when converting decimal number to binary. First, divide the number by 2. Second, repeat the divisions, then record the remainders. For example, convert the decimal number 25 to binary. Here's the solution. 25 divided by 2 equals 12, remainder 1. 12 divided by 2 equals 6. 6 divided by 2 equals 3. 3 divided by 2 equals 1, remainder 1. 1 divided by 2 equals 0, remainder 1. Now, take the remainders from bottom to top. We have 11001. So the binary representation of decimal number 25 is 1101. Next up is the binary to octal conversion. Here are the steps to follow when converting binary numbers to octal. First, group the binary digits into sets of 3 starting from the right. Second, convert each group into its octal equivalent. Then, write the octal digits together. For example, convert the binary number 101110 to octal. That will be 101110 when grouped into sets of 3. Then, convert each group into its octal equivalent. 101 was 1 times 2 raised to the power of 0 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 2 equals 4 plus 0 plus 1 equals 5. Next is 110. 0 times 2 raised to the power of 0 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 2. That will be 4 plus 2 equals 0 equals 6. Write the octal digits together. That will be 56. To verify, we convert both the binary and octal back to decimal. So, first is the binary 101110. That will be 0 times 2 raised to the power of 0 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 2 and 1 times 2 raised to the power of 3. So, the octal representation of 101110 is 56. Next is decimal to octal conversion. Here are the steps to follow when converting decimal number to octal. Step 1. Divide the decimal number by 8, noting the quotient and the remainder. Step 2. Repeat the division using the quotient as the new dividend until the quotient is 0. Step 3. Record the remainders from bottom to top. For example, convert the decimal number 46 to octal. Here's the solution. 46 divided by 8 equals 8, remainder 3. 5 divided by 8 equals 0, remainder 5. The remainders are 5 and 6. So the octal equivalent of the decimal 46 is 56. To verify, convert the octal number 56 back to decimal. That will be 6 times 8 raised to the power of 0 plus 5 times 8 raised to the power of 1 equals 5 times 8 plus 6 equals 46. So, the conversion is correct. Then, octal to decimal conversion. Here are the steps to follow when converting octal number to decimal. Step 1. Write down the octal number. Step 2. Multiply each digit by 8 raised to the power of its position starting from 0 on the right. Then, sum the results. For example, convert the octal number 157 to decimal. Here's the solution. 1 times 8 raised to the power of 2 equals 1 times 64 equals 64. 5 times 8 raised to the power of 1 equals 5 times 8 equals 40. 7 times 8 raised to the power of 0 equals 7 times 1 equals 7. Then add 64 plus 40 plus 7 equals 111. So, the decimal equivalent of the octal number 157 is 111. To verify, we will convert the decimal number 111 back to octal by dividing it by 8. That will be 111 divided by 8 equals 13, remainder 7. 13 divided by 8 equals 1, remainder 5. And 1 divided by 8 equals 0, remainder 1. Read the number from bottom to top. It gives us 157, which matches the original octal number. That's all my part. Thank you for listening.
Good day everyone, I am Berlin Bulalakaw from BSIT 1B. At this point, I am going to discuss the binary to hexadecimal conversion. Here are the steps to follow when converting binary number to hexadecimal. Step 1. Group the binary digits into sets of 4, starting from the right. If necessary, add leading zeros to make the leftmost group contain exactly 4 digits. Step 2. Convert each 4-bit group into its corresponding hexadecimal digits. Step 3. Combine the hexadecimal digits to get the final result. Here are the binary to hexadecimal mapping. For example, convert the 10110 1110101 to hexadecimal. Group as 0010 1105 1101 0101. 0010 is equal to 1101 is equal D 1101 D 0101 equals 5. Verify, convert both the binary and hexadecimal numbers back to decimal. 1 times 2 raised to the power of 0 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 4 plus 1 times 2 raised to the power of 5 plus 1 times 2 raised to the power of 6 plus 0 times 2 raised to the power of 7 plus 1 times 2 raised to the power of 8 plus 1 times 2 raised to the power of 9 plus 0 times 2 raised to the power of 10 plus 1 times 2 raised to the power of 11 is equal to 2048 plus 5. Next is decimal to hexadecimal conversion. Here are the steps. Step 1. Divide the decimal number by 16. Step 2. Divide the quotient from the previous division by the 16. Step 3. Write the remainders in reverse order. For example, convert 254 from decimal to hexadecimal. 254 divided by 16 equals 15, remainder 14 E. 15 divided by 16 equals 0, remainder 15 F. Reading the remainders from bottom to top gives F or if. So, the decimal number 254 is equal to FE in hexadecimal. Verify, convert FE back to decimal and check if we get 254. Step 1. Understand hexadecimal notation. In hexadecimal, each digit represents a power of 16. The rightmost digit represents 16 raised to the power of 0, the next is 16 raised to the power of 1, and so on. Step 2. Convert hexadecimal if e back to decimal. F in hexadecimal is 15. E in hexadecimal is 14. If e hex is equal, if f times 16 raised to the power of 1 plus e times 16 raised to the power of 0. Substitute the values. If e hex is equal 15 times 16 plus 14 times 1 is equal 240 plus 14 is equal 254. Octal to hexadecimal conversion. To convert a number from octal to hexadecimal, the most straightforward method is to first convert the octal number to decimal and then from decimal to hexadecimal. For example, convert the octal number 175 to hexadecimal. Step 1. Convert 175 to decimal. 5 times 8 raised to the power of 0 plus 7 times 8 raised to the power of 1 plus 1 times 8 raised to the power of 2. Calculate. 1 times 8 raised to the power of 2 equals 1 times 64 equals 64. 7 times 8 raised to the power of 1 equals 7 times 8 equals 56. 5 times 8 raised to the power of 0 equals 5 times 1 equals 5. 64 plus 56 plus 5 equals 125. So, 175 octal is equal 125 to n decimal. Step 2. Convert 125 to hexadecimal. 125 divided by 16 equals 7 remainder 13 d. 7 divided by 16 equals 0 remainder 7 equals 7. Now, write the remainders in reverse order. 7d. So 125 decimal is equal to 7d in hexadecimal.
Once again, good evening everyone. I am Emeline Dairo and so today I am going to discuss about data units. So let's define first what is data units. So data units measures the size of digital information, and understanding these units is essential for dealing with data storage and processing. Data units are like measuring cups for digital information. So data units are like measuring cups for digital information. They help us understand how much data we're dealing with, whether it's the size of a file, the capacity of a storage device, or the speed of a data connection. The most commonly used units of data storage capacity are the bit, the capacity of a system that has only 2 states, and the byte, which is equivalent to 8 bits. Under data units are bit, byte, kilobyte, megabyte, gigabyte, terabyte, and etc. So, mauna sila ang mga under sa data units. Now, let's proceed to bit. So, what is bit, by the way? So, a bit or binary digit is the most basic and smallest unit of data that a computer can process and store. So, a bit is always in one of 2 physical states similar to an on or off light switch. The state is represented by a single binary value, usually a 0 or 1. Bits are used to measure data transfer rates, like for example, internet speed, megabits per second, and etc. So that is bits. So imagine a tiny switch that can either on or off. So that's essentially what a bit is. It is the most basic unit of data in computers, representing a single binary digit, which can be either 0 or off or 1 on. Think of it like a light bulb. So, ato siyang i-relate sa light bulb. So, ang off, nag-represent siya sa value nga 0, and ang on, nag-represent sa value nga 1. While a single bit is very small, it is still a fundamental building block of all digital information, because without bits, our computer wouldn't be able to process, store, or transmit any data. Now, let's move on to byte. So, what is byte or bytes? So, byte is the basic unit of information in computer storage and processing. A byte consists of 8 adjacent binary digits or bits, and each of which consists of a 0 or 1. Originally, a byte was any string or more than one bit that made up a small piece of information like a single character. So, a byte is like a small box that holds a single piece of information. It's a group of 8 bits, and each bit can be either a 0 or 1. A byte can represent a single character like a letter, number, or punctuation mark. This is because with 8 bits, you can create 256 different combinations, 2 raised to the power of 8, which is enough to represent all the characters in common computer alphabets. Bytes are used to store all kinds of basic data in computers, including numbers, symbols, and even instruction for the computer to follow. So, imagine a book. So, in a book, a bit is a single letter in a book, and a byte is a word in a book. So, ang bit is, kung ang bit is single letter lang siya sa isa ka libro, ang byte is word na siya sa isa. A byte is still a small unit of information, but it's large enough to represent meaningful pieces of data. It's the foundation for storing and processing information in computers. And that's all for byte. Now, let's proceed to kilobyte. So, what is kilobyte? So, kilobyte is a multiple of the unit byte for digital information. The International System of Unit, or SI, defines the prefix kilo as a multiplication factor of 1000. Therefore, 1 kilobyte is 1000 byte. So, imagine a small book containing a few hundred words. That's about the size of a kilobyte or KB. It's a unit of data that's bigger than a byte but still relatively small. 1 kilobyte is 1024 bytes, and it's almost like 1000 bytes, but technically, it's a bit more. Kung ang byte is a single word in a book, ang kilobyte is a short paragraph na in a book. And it's like a small storage container for a small amount of information. While a kilobyte is small, it's still a significant unit for storing and transmitting everyday digital data. Next, we have megabyte. Let's proceed to megabyte. So, what is megabyte? Megabyte is a unit of data capacity that is equal to 1 million bytes. So, think of a megabyte as a thick novel containing thousands of words. It's a much larger unit of data than a kilobyte, and it's commonly used to measure the size of things like photos, music files, small videos, and etc. 1 megabyte or MB is equal to 1024 kilobytes. So this is roughly equivalent to 1 million bytes. Kung ang kilobyte is short paragraph siya in a book, a megabyte is a whole chapter in a book. Megabytes is a specific unit of data that's equal to about 1 billion bytes of data. The term gigabyte is typically used to describe the amount of stored data or the capacity of a storage device. For example, an HDD might offer 500 gigabyte of raw capacity but is currently storing only 200 gigabyte of data. A gigabyte is like a whole library filled with thousands of books. It's a massive unit of data, much larger than a megabyte, and it's used to measure the size of things like movies, games, and large software programs. Gigabytes are a common unit for large digital files and storage devices. While a megabyte is like a chapter, a gigabyte is like a whole library holding a massive amount of information. Next is terabyte. So terabyte is a unit of digital data that is equal to about 1 trillion bytes. Imagine a vast digital warehouse filled with thousands of libraries, each containing millions of books. That's the scale of a terabyte. It's a colossal unit of data much larger than a gigabyte, and it's used to measure the size of things like large databases, high-resolution images, and high-quality video footage. Terabytes are a common unit for massive data storage and processing. While a gigabyte is like a library, a terabyte is like a whole warehouse filled with libraries holding an enormous amount of information. So in summary, bit is representing a single binary digit, 0 or 1, and then ang byte is a group of 8 bits. And then a kilobyte is about 1,000 bytes. Ang megabyte is roughly equivalent to 1 million bytes, and then ang gigabyte is about 1 billion bytes, and then ang terabyte is approximately 1 trillion bytes. So think of these units like a measuring distance. Sa measuring distance, ang bit is like a millimeter, tiny and hard to visualize. And then ang byte is like a centimeter, a small but recognizable unit. And then ang kilobyte is like a meter, a common unit for everyday objects. And then ang megabyte is like a kilometer, a unit for larger distances. And then ang gigabyte is like 1,000 kilometers, a unit for very large distances. We think these units in a book. Ang bit in a book is a single letter, and then byte is a word in a book, and then kilobyte is a paragraph. A megabyte is whole chapter in a book, and then gigabyte is whole library that's full of books, and then terabyte is a vast digital warehouse filled with thousands of libraries. Sa ganun yung pagkakasunod-sunod and yung pag-identify ng data units. So that's all for data units. Thank you and good day.
Good day everyone, I am April Grace Bustamante from BSIT 1B. Text representation in computer science refers to the process of converting text into a machine-digestible form, such as vectorial representations, to enable machine learning algorithms to analyze and understand textual data. Text representation is the foundation for enabling machines to perform tasks like language translation, text summarization, and sentiment analysis. Without an appropriate method of representing text, algorithm would be unable to process the unstructured nature of human language. The goal of text representation is to convert words, sentences, and documents into numerical formats that retain the meaning and context of the original languages as much as possible. This transformation is essential because machines work with numbers, not words. A text representation is a way of conveying information, ideas, or concepts using written or typed words. It involves translating abstract ideas or visual elements into languages that can be understood through reading. This can include descriptions, explanations, summaries, or the encoding of complex data into a readable format. There are two most common encoding systems. First, ASCII stands for American Standard Code for Information Interchange. ASCII has 7-bit or 8-bit encoding, only supports English characters and limited set of symbols, primarily designed for early American text processing and data transmissions. One of the oldest text encoding schemes developed in the 1960s, it uses 7 bits to represent characters, which includes control characters like new line or tab, punctuation marks, digits, and the English alphabet, which is why it is often seen as insufficient for global text representation. For example, the letter A is represented by the number 65 in ASCII. A new line character or line break is represented by 10 in decimal. Extended ASCII, an 8-bit version of ASCII which uses 8 bits or 1 byte for each character instead of 7 bit. It extends the ASCII standard to 256 characters from 0 to 255. Next up is the Unicode. It's a standardized character encoding system designed to provide a unique number or code point for every character used in the word writing systems, regardless of the platform, programs, or language. For example, let's consider the letter A. In Unicode, the letter A is represented as uni plus 0041 in hexadecimal. This value is equivalent to 65 in decimal and 100010 in binary. UTF-8 or Unicode Transformation 8-bit is an encoding defined by the International Organization for Standardization. UTF-8 is a variable width encoding standard. This means that it encodes each code point with a different numbers of bytes between 1 and 4. As a space-saving measure, commonly used code points are represented by.
Once again, good day everyone. I am Ginalyn Ruiz from SIT 1B. At this point, I am going to discuss about file format. File format. A file format is a standard way of organizing and storing digital data in a file, making it recognizable and readable with specific software, hardware, or operating systems. Ang file format mao ang paagi sa pag-organisa o pag-save sa digital data sa usa ka file nga naghatag sa mga software o hardware nga makabasa o makagamit niini. For example, in document we have .docs. In images we have .jpeg, and audio we have .mp3, and in video, we have .mp4. Next, the 4 basic concepts of file format. The first one is structure. This refers to how the data in the file is organized or arranged. Ang buod pasabot ani ay ang estruktura mao ang sistemang pagpangkat-pangkat o pagkasunod-sunod sa mga datos sulod sa usa ka file. Naghatag kini sa mabilis ug maayong pag-imbak, pagkuha ug paggamit sa mga datos. The second one is encoding. This defines how data is represented in the file, typically in terms of character encoding. Ang encoding mao ang proseso sa paghubad sa datos ngadto sa digital na format sulod sa usa ka file. Pinaagi sa mga sistema sa pag-encode sa mga titik sama sa ASCII o Unicode. Naghatag kini sa mga computer nga maunawaan, iimbak o ipakita ang datos ng maayos. The third one is extension. The file extension is part of the file's name and helps identify its format. This extension can inform the operating system and software about how to handle or open the file. Ang extension sa file maong asa ka suffix na gidugtong sa ngalan sa file. Nagpahibalo sa format niini ug naghatag daan sa operating system o software nga kilalan o gamiton kini ng angay. Ang extension kini nagaserve nga identifier naghatag instruction sa sistema kung unsang aplikasyon o programa ang gamiton para sa buksan o prosesohon ang file. The last one is metadata. This is additional information about the file such as the file type, size, creation date, or author. Metadata can be embedded within the file or stored separately, but it provides an important context that helps software understand how to work with the file beyond its raw data. Ang metadata naghatag og daghang impormasyon may tungod sa usa ka file sama sa typo sa file, sukat, pitsa sa paglikha ug may akda. Naghatag og konteksto sa software kung unsaon pagtrabaho sa file gawas sa raw data. Ang metadata mahimong mahikayon sa sulod sa file o mahimong gisalbayan sa ibabaw. Nagpapadali sa mahusayong pamamahala sa file, pagpangita o pagkuha. Let's proceed to the 10 main types of file formats. Number 1. Text file formats. These store plain text or formatted text. Ang mga format sa file sa teksto nagpasabot sa pagkakaayos o ekstraktora sa mga datos sa teksto sa mga file. Lakip ang mga format sama sa TXT, CSV, HTML, XML, o JSON nga may kalainang mga katangian o aplikasyon. Ang mga format na mga ito nagkalain sa ekstraktora, kompatibilidad o paggamit, busa na kinahanglan sa pagpili sa tamang format, sumala sa sulod, platform o mga panginahanglan sa datos. Number 2. Image file formats. These store graphical images, each with different compression or quality attributes. Ang mga format sa file sa litrato nagpasabot sa mga pamamaraan sa pag-ayos o pag-imbak sa datos sa litrato sa digital sama sa JPEG, PNG, GIF, BMP, TIFF, o CVG. Ang matag format nagkalain ng mga katangian, benepisyo o aplikasyon. Nagpapadala sa mga pagpili alang sa mga particular nga gamit sama sa pagbuo sa web. Disenyo sa grafika o profesional nga pagkuha sa litrato. 3. Audio file formats. These store sound and music data. Ang mga format sa file sa audio nagpasabot sa mga pamamaraan sa pag-imbak o pag-encode sa datos sa audio. Sama sa WEV, MP3, ESC, FLEC, o AIFF. Ang matag format nagkalainang mga katangian, benepisyo, o aplikasyon. Nagpapadala sa mga pagpili alang sa mga particular nga mga gamit sama sa pag-stream sa musika, pag-edit sa audio, o paggawa sa podcast. That's all my part. Thank you.
Good day everyone, I am Rochelle Sabanal from ECT 1B. We will going to discuss about a video file format. Okay, what is video file format? Ang video file format ay isang uri ng format o struktura na ginagamit upang mag-imbak at mag-compress ng video data, Tinutukoy nito kung paano nakaayos ang mga bits at bytes ng video sa isang file at kung paano ito maaaring i-play o i-process ng mga devices o software. Halimbawa ng mga kilalang video file format ay MP4, EVI, MOV at MKV. Ang bawat format ay may iba't ibang kalidad, laki at compatibility sa mga device o platform. Next, document file format. These are used for text-based documents, including presentations and spreadsheets. Ang document file format ay isang uri ng format na ginagamit upang mag-imbak ng mga dokumento sa isang particular at iba pang nilalaman sa loob ng file, at kung paano ito mabubuksan o ma-edit gamit ang software o application. Halimbawa ng mga kilalang document file formats ay DOCX, Word, PDF, TXT at RTF. Ang bawat format ay may kanya-kanyang gamit, kalidad at compatibility sa iba't ibang devices at software. Next, compressed file formats. These formats are used for reducing file size by storing data in compressed form. And ang compressed file format ay isang uri ng file format na ginagamit upang bawasan ang laki ng isang file o grupo ng mga file. Ginagawa ito upang mas madaling isave, ipadala at i-download ang mga file. Sa pamamagitan ng compression, binabawasan ang espasyo na kinukuha ng mga file nang hindi nawawala ang mahalagang impormasyon. Halimbawa ng mga compressed file formats ay ZIP, RER at 7Z. Kapag binuksan ang mga compressed file, maaari mong i-extract o ibalik ang orihinal na nilalaman ng mga ito. Database file formats. This store structured data in a way that is accessible to database management system. Ang database management system file format ay isang uri ng format na ginagamit upang mag-imbak at ayusin ang malalaking halaga ng data sa isang sistematikong paraan. Ang mga database file ay may struktura na nagpapahintulot sa mabilis na pag-access, paghahanap at pagbabago ng impormasyon. Halimbawa ng mga database file formats ay SQL, MDB, Microsoft Access at DBF. Ang bawat format ay may particular na gamit at compatible sa iba't ibang database management systems tulad ng MySQL o Microsoft Access. Next is executable file formats. This format contains instructions that computer can execute directly. Ang executable file format ay isang uri ng file na naglalaman ng mga utos o programang maaring patakbuhin ng computer. Kapag binuksan ang file na ito, automatikong isinasagawa ang system ang mga instruction na nasa loob ng file. Karaniwang ginagamit ito para sa magpatakbo ng software o applications. Halimbawa ng mga executable file formats ay EXE para sa Windows, EPP para sa Mac OS at BIN. Ang mga file na ito ay naglalaman ng code na direktang tinatanggap at isinasagawa ng operating system. Web file formats. These are used for web developments and internet-based media. Ang web file formats ay mga uri ng file na ginagamit para sa pagpapakita ng nilalaman sa internet. Kadalasan, ang mga file na ito ay mga format na angkop para sa mabilis na pag-load at pagpapakita sa mga web browser. Halimbawa ng mga web file formats ay HTML o Hypertext Markup Language para sa mga web page, CSS o Cascading Style Sheets para sa disenyo, JPEG at PNG para sa mga imahe, at ang MP4 sa mga video. Ang mga format na ito ay tumutulong sa paggawa ng website at web applications na madaling i-access at gamitin. Next, system and configuration file formats. This store system settings or configuration data. Ang system and configuration file ay mga file na naglalaman ng mga setting at impormasyon na ginagamit upang ng operating system o software upang gumana ng maayos. Ang mga file na ito ay may mga utos, parameters at preferences na nagkokontrol kung paano mag-ooperate ang isang system o application. Halimbawa ng system files ay DLL o Dynamic Click library sa Windows at CFG configuration file na ginagamit ng iba't ibang programs para i-configure ang kanilang behavior. Ang mga configuration files ay madalas na hindi binago ng mga ordinaryong user, maliban na lang kung kinakailangan para sa mga advanced na setting.
Hey everyone, my name is Jeremy Aldefas from Base IT 1B. Introduction of Database. Database is an organized collection of data that is stored and accessed electronically. It provides an structured way to manage and manipulate large amount of data. Effectively, databases are used in a wide range of applications from website and mobile apps to business system and scientific research. Ang database ay isang organisadong koleksyon ng data na nakaimbak at na-assist sa elektronikong paraan. Nagbibigay ito ng kabalangkas na paraan upang pamahalaan at manipulahin ang malalaking halaga ng data. Nang mahusay ginagamit ang mga data sa malawak na hanay ng mga application mula sa mga website at mobile app hanggang sa mga sistema ng negosyo at scientifikong pananaliksik. Object-oriented database. Store data has objects similar to how data is present in object-oriented programming. 5. Graph database. Designed to store and analyze the relationship between data points. They use graph structure with nodes, edges, and properties to present and store data. Object-oriented data. Mag-imbak ng data bilang mga bagay katulad ng kung paano kinakatawan ang data sa object. Oriented ng programming. Graph database. Identification upang mag-imbak at magsuri ng mga ugnayan sa pagitan ng mga punto ng data. Gumamit sila ng mga istruktura na graph na may node, gilid at mga katangian upang kumatawan at mag-imbak ng data. At yun lang po, maraming salamat.